So we've been exploring the idea of object-oriented programming in terms of classes and objects, and what we're going to introduce now is a couple of special methods. So we've talked about attributes of a class, what's the kind of information that a class can store, and we've talked about methods that a class can have. So the different ways to operate on those attributes or that data. And what we're going to introduce now is a way to so a couple of special methods that can be used with classes. So before we had defined a weather class, and in the main program, and it was a very simple weather class, and in the main program we had set a date, a temperature, a relative humidity, a wind speed, and a wind direction. And if you remember, over on the side, PyCharm was kind of complaining at us a little bit. It was giving us warnings, nothing in red, so the program's still run, but it was saying, what is this variable date, temperature, what are these attributes that you're defining? I haven't seen these before. It turns out that there is a way to actually define these things or let Python know that your class is going to have these attributes inside the code. And you do that through the init method. So it looks a little funny because there's a double underscore before the init. And this is a method, right? It starts with a def. Could be a procedure or a function. And it has a double underscore before and a double underscore after. The reason for that is simple. When there's certain kinds of built-in methods in a programming language, generally the underscores are put there because it's not the kind of name that you typically would use. So it looks unusual, and that's exactly the point. So double underscore init, double underscore, not something that generally people would think of. Okay, so what this means, init literally means initialization. So down here in the old code, we had instantiated a class weather. We called it today. And then we had assigned initial value for date, temperature, relative humidity, wind speed, and wind direction. What we're going to do now is define this init method. And what happens is when we instantiate the variable, so I'm going to declare a variable today to be of type weather class, so this is an object, this is the class, then when that happens, when you declare that variable today to be of type weather, the first thing that goes on is this init method is automatically called. So you don't have to do anything. Python takes care of that for you. So this is automatically going to be called, and notice that we have to pass in a few things here. So we're going to pass in all these variables we had listed before. And up here, I've defined those inside the init method, date, temp, relative humidity, wind speed, and wind direction. And notice that I have the self variable here. And then inside of here, I'm going to define these attributes for the weather class. So each object of type weather is going to have a date, a temperature, relative humidity, wind speed, and wind direction. And PyCharm is no longer complaining at me. Well, it's got one little complaint over here, but it has nothing to do with the fact that I'm defining attributes that doesn't know what they are. Because I'm declaring these attributes inside of the init class, it says, oh, okay, I understand that you want these attributes to be part of this class, and that's fine with me. Okay, so the init is something that's going to be called, again, anytime that you instantiate or create a variable of type weather. And then we have some other methods in here. We have a method to convert from Fahrenheit to Celsius. We have a method to compute wind chill. And then we have the print weather method, which prints out the date, the temperature, relative humidity, and so on in a relatively nice way. Makes it very legible and whatever. So as a method, I can call today.printweather. And again, it has this self variable. So the self variable refers to the object today. So when print weather is called, we don't even have to pass in self. Self gets passed in as today automatically, so it's not something we have to worry about. It refers to the object, not the class. So if I declare a different variable, highlight and paste here. And maybe call it tomorrow. And make that the 18th. And the wind's going to be out of the northeast. And I'm going to run this. And there's two things that I want to talk about here when I run this. So we can see where the two today.print weather commands are called. And so I get a relative humidity of 78% from up here. Wind speed is 10 miles per hour out of the northwest, and it calculates the wind chill as a float. And then we get the next day, which is tomorrow.print weather. So a couple of things have happened here inside this code. First, notice that how nice and tidy this is down here. The bulk of the code is actually in defining the class, and it's exactly the way it should be. A well-defined class is going to make using that class simple to do. So this stuff down here is pretty simple. And the other thing to notice is that up here I'm referencing self.date, self.temperature, self.relative humidity, and so on. How did those things get set? Well, they got set through this init up here. So when we constructed this for today dot date, for example. So think of this self as today.date when we instantiate with today becomes 11/17/2502. So after we call this init, we could do print today.date, and I'll add in a new line. And I'm getting yelled at. Why am I getting yelled at? Missing close quote. What are you yapping about? Okay. And I made this window very small. So up here is the date, today.date, and what happened is when we call the init with self in this case refers to today, and we set today.date equal to that in a init. And again, a init is automatically called anytime we instantiate. And down here, when we call with tomorrow, self becomes up here self.date, or I'm sorry, tomorrow.date. So tomorrow's date is 11/18/2502, and we can see that when we call tomorrow with print weather, it comes in and prints self.date. Well, in this case, it means tomorrow.date. So I want to make clear that self refers to the object, and the object is instantiating the class. It doesn't refer to the class. Remember, the class is the blueprint, and the object is the actual building. Okay, so again, two things I want to emphasize from this portion of the video. Init is automatically called as long as you define it with double underscore, init double underscore. The self has to be in there. And so that gives you a way to initialize the attributes of your class. And the other thing I'm trying to emphasize is that the self here references the object. So in this case, self would reference today. In this case, self would reference tomorrow. Okay, there are other built-in kinds of methods. So I'm going over here, and we have essentially the same thing we had before, except for over here I had a print weather method, and I've changed that. It turns out there is another built-in method that one can use, like a init. In this case, it's called double underscore string. So again, not something you typically would type. That's why the double underscores are there. And this returns a string. And that string, as it turns out, is exactly the same thing as I had over here. I've just made it a string instead of a bunch of prints. And when you define a string method like this for a class, then instead of calling today.printWeather, I can just say print the class today. And when I do that, print is going to go to the class and say, do you have a string method defined? And in this case, I do have a string method defined. It's right there. And it's going to say, oh, okay, what do you want to tell me? And this will return a string, which print will then print out. Notice that we're using self again, so self.date, self.temperature, and so on. So whatever object we call it with, that's what we're going to get, the date, temperature, and so on for that object. You've used this method before. So again, everything in Python is an object. And when we've used numbers and wanted to put them in a string, we had to call a string method on them. And I've used this terminology before. So now you understand what it means. Integers, floats, etc. actually have a built-in double underscore str, double underscore. You could go out and actually find the code. If you wanted to sort through Python, you could find the code where that was defined. But they do have string methods. And so anytime I call print or string of that class, then it's going to print out whatever code I put in here. So I'm going to run the string method. And it doesn't really do anything output-wise different than what I had done before. So it prints out the date, the temperature, relative humidity, wind speed, and wind chill, and so on. But the way I call it is different. I can just use a print command, or I can just use it as a string. So here's another way to use the string method. I print out that string there with new lines, and then I just say string today. And it automatically comes up again and calls this code where I formatted it with a date, the temperature, new line in between them, degrees and degrees Fahrenheit, relative humidity, and so on. Just to emphasize this concept a little bit further, suppose that I change the string method to something really silly. So I'm going to change the string method so it just returns the number 2. Then in that case, no matter what I define weather to be, so I have today again, this is the exact same weather conditions we've been using this whole video. When I print today, print's going to come up here and say, okay, you have a string method defined. What kind of string am I going to print out? 2. Okay, I can do that. Let's try that. So it prints out 2. And then here's another way to use a string method, 2. So this method defines how your class is going to interact with a string command and essentially the print command. So 2 built-in methods that we should be aware of, init and string. And the last thing I'm going to do is show you a trick with the initialization. And the idea here is that up until now, I have defined the date and temperature and so on inside the initialization. So if you were reading things in from a file, this might make a lot of sense that I would want to do this way. I could read in all this information from a file, or maybe I have a database on weather that I want to read in. I could read those in and put those into an object, and that would work great. But what if I wanted instead, on occasion, to have the weather typed in from a keyboard? So maybe I want to input a new weather for today and then store that back to my database. So I need a way to handle that. And the way that I had a init defined before, in this first one, and well, the other 2 programs, it's expecting to get a date, temperature, relative humidity, wind speed, and wind direction. But if I don't have anything to pass, if I'm expecting that stuff to be inputted, I don't have anything to pass to it. So how do I handle that? Well, remember that we can handle default parameters. So up here, I've given all of the parameters, date, temperature, relative humidity, wind speed, and wind direction, default values of none. And PyCharm is going to complain to me because I put spaces around those. Stop complaining, PyCharm. Which then allows me to check whether or not, in this case, I'm actually passing this information. So again, you can think of this as I read this in from a file and want to pass this information into today. Or I might want to type in the weather well, I guess this doesn't make sense this way. I should have had this yesterday. Pass it in from a file, and today I'm going to type in the weather. And up here, what's going to happen is I'm going to check, are all of these values none? And if they are, that must mean I want to input those values. And otherwise, if they're not none, that must mean I pass them in. And then this is just the same old code as before. And so we run this. And what's going to happen is, in this first case, we've passed all these values in, and so it's just going to set the class attributes to those values that I passed in. And in the second case, where I'm calling without any information in here, then all these are going to default to none, and we're going to go into this, and it's going to ask me to input the date. So today is 12/3/2014, and the temperature, I don't know what it is, but it feels like it's -50, so let's go with that. Relative humidity, it's kind of dry out. Just making this up. Wind speed, 500 miles an hour, and that's coming from every direction, but we'll say northeast. Well, capitalize it. And then in the end, I just print out tomorrow using my built-in string method. Okay, so again, what should you have gotten out of this video? The two built-in init and string methods, and then there's this little trick that allows you to use the init in two different ways. So you can hard code the information in there yourself, or get it from a file or some other source, or you can have it get it from the keyboard from the user using, again, default values for your parameters.